Hello, welcome to Intellect Menti. Let's get started. Our today's topic is modern periodic table. Modern periodic table is given by scientist Henry Moseley. Today we will discuss in detail how he arranged the elements in modern periodic table, why we called it as modern periodic table, and other things regarding to this complete topic. Let's begin with first modern periodic law. As we all know, Dobereiner, Mendeleev, and the Newland. These three scientists use criteria atomic mass number as the fundamental property, we can say, to arrange the all elements in increasing order of their atomic mass numbers. But Henry was the first scientist who used atomic numbers as a fundamental property. So this is a big difference between these three discoveries and this discovery. Now, the question arises, why Mendeleev, Newland and Dobereiner could not use the atomic numbers? Because after the discovery of electrons at the time of Henry's discovery, there is a discovery of electron. So scientists started exploring the relation between what atomic numbers and the electrons. So they are starting to exploring the relation between these two, and because of that discovery of electrons, Henry used atomic number as the fundamental property rather than atomic mass. On the basis of this, we have this law that is called as modern periodic law. Now, this modern periodic law is similar to your Mendeleev's periodic law. Just the one word is changed. Atomic mass numbers, instead of that, we have atomic number here. So, what is this modern periodic law we have? Modern periodic law states that the properties of the elements are the periodic function of their atomic numbers. So on the basis of this law, we have modern periodic table. Modern periodic table also called as long form of periodic table. So how it is and why we will see in the next parts. So let's take a look here. We have to study what? We have to study in this structure of the modern periodic table and periodic trends in this. These are the two important part that we have to study in this topic. So what I'm going to do is today I will introduce briefly structure of the modern periodic table, and the next two videos we are going to see groups, periods and the blocks, these three topics. So once we will finish with structure and then we will move to periodic trends. So without wasting our time, let's begin with the structure of modern periodic table. As you can see on the screen, this is the basic outline of modern periodic table. So what we can see on the screen is there are vertical columns. So these vertical columns we are called as groups. Second, there are horizontal rows. These horizontal rows we called as what? We called as periods. And what is the different in this? These groups and periods are very similar to your Mendeleev's periodic table, but he divided the whole periodic table in some blocks. So there were four blocks: S block, P block, D block, and the F block. So basically, your modern periodic table is based on these three: groups, periods, and the blocks. And one more topic you have to remember, that is zigzag line. So this is the structure. This contains the structure of periodic table. So we will see in detail these all topics. But before that, let's try to understand how he arranged the elements in increasing order of atomic numbers. So he started with the hydrogen. As we know, hydrogen having atomic number 1. So see here the hydrogen 1 atomic number. Then we have here helium which having atomic number 2. Then he can arrange the lithium with atomic number 3, beryllium atomic number 4, boron atomic number 5, carbon atomic number 6, okay, nitrogen 7, oxygen 8, and fluorine 9. So in that similar way, what you can observe here is 1, 2, then 3, 4. This is what? Increasing order of what? Atomic number. So in this way, he arranged all the elements in increasing order of atomic numbers. So let's begin with the next very important fundamental property used in this all classification, that is electronic configuration. We already had detailed discussion regarding to electronic configuration. Okay, please kindly go through the previous videos. So let's begin with the electronic configuration. So now this electronic configuration is very important here. Let's begin with the first group number 1. So in this period, how many in this table, how many groups are there? It is starting from 1 and to end with 18. So there are 18 groups and there are 1 to 7 periods in this modern periodic table. So each and every element which possesses the similar electronic configuration, they placed in similar groups. Just for the example, see this. This is the hydrogen, this is the lithium, and this is sodium. So what you can see here is hydrogen having atomic number 1, so it's configuration 1. Lithium, it having what? 3, so it is 2, 1. Okay, and we have what? Potassium, you have 11, so its configuration is 2, 8, 1. It means they're having some similarity in their configuration. We can say that all elements possess outermost shell with a 1 electron. So they all are placed in one group. Similarly, you can see about this period, that is a lithium, then you have beryllium, then you have here boron. So see here, lithium, beryllium, boron, and so on. So if you will see here, lithium having what? Configuration atomic number 3. So it will be what? 2, 1 for lithium. What will be beryllium here? Beryllium will be what? 2, 4. Sorry, 2, 2. And the boron will be what? 2, 3. So what you can see? All contains number of shells is what? 2. So here, this electronic configuration played very important role in modern periodic table. So this is how this whole structure of modern periodic table we will see in detail in the next sessions, that is groups, periods, and blocks. Till then, thank you so much.